Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hello dear students, good evening. Welcome back to the beautiful channel of Brilliant Katha. We continue our live DPP discussion to prepare for the phase 2 of JEE Main examinations. Okay, today we discuss the chapters oscillations and waves. Okay, the first question is, the motion of a mass on a spring with a spring constant K is as shown in figure. The equation of motion is given by x of t is equal to a sin omega t plus b cos omega t. Okay, with omega is equal to root of k by m. Yes. Suppose that at time t is equal to 0, the position is lettered as x of 0 and the velocity given as v of 0. Okay. Then its displacement can also be represented as x of t is equal to c cos omega t minus phi. Okay, where c and phi are what? These are the options. See here, simple harmonic motion is given that x of t is equal to a sin omega t plus b cos omega t. Okay, x is equal to a sin omega t plus b cos omega t. Yes. Yes. Now it is also given that this x is equal to c into cos of omega t minus phi. Okay. It's also given that this x is equal to c into cos of omega t minus phi. Okay. And here two letters are given at time t0, the position is x of 0 and velocity is v of 0. Then what are the values of c and phi are asked. Okay. Now listen. See here we have at time t is equal to 0, we have x is equal to a into sin 0 plus b into cos 0, that is b into 1, that is b, and this is given as x of 0 as b. Okay, so the value of b is actually x of 0. Yes. Now the velocity of this simple harmonic motion, by differentiating it once with the time, we get a omega cos omega t plus b omega sin omega t. Okay. Now again at a time t is equal to 0, we get this as, this is a omega, this term is a omega, and the second term is 0, and this is given in the question as v of 0, which means the value of a is equal to v of 0 divided by omega. Okay, two constants we already obtained. B is equal to x of 0 and A is equal to V of 0 divided by omega. Yes. Now the next step is we are writing this given x is equal to A sine of omega t plus B into cos of omega t into this term. For that we do that A sine omega t plus this one also we are changing this cos omega t into sine. First, how it is done that sine of omega t plus 90 we can do. Okay, sine 90 plus theta is cos theta. Sine 90 plus theta is cos theta. Okay. Now we can do the phasor diagram solution method. For that, we are taking two axes in which A is considered along x-axis. Suppose this amplitude A is considered along x-axis. Then this direction is taken as the phase omega t. See, this amplitude A and the phase angle there is omega t. So this direction is considered as omega t. Then the amplitude B is 90 degree ahead of omega t. Listen, amplitude B is 90 degree ahead of omega t means B will be in this direction. Okay. Then the vector sum of these two vectors will be the resultant amplitude of these two functions. The vector sum of these two is, that is this one, and it is C, which is root of A square plus B square. Okay, this is the resultant amplitude, because this one we are going to write in this format. Now here amplitude is C. Clear? And let this angle be some, here alpha already given, phi is already given, so I am taking this as alpha. Okay. Now this is the resultant amplitude means we can write this x is equal to this resultant amplitude C into sine of what, this direction is already omega t plus alpha. Okay, sine of omega t plus alpha. Okay. Now we can convert this into cosine function, that because this is already in cosine given. Okay, C into cos of this one, what we can write, that here omega t is here. See, omega t minus, I can write this as 90 minus alpha. Look into it. See, actually this is omega t plus alpha minus 90. Cos theta minus 90 is sin theta. Cos theta minus 90 is sin theta. So this is true. This is okay. You understood? Now what is this C value is here root of A square plus B square. Clear? C value is equal to root of A square plus B square. Yeah. Now what is A is here? A is V of 0 by omega. V of 0 by omega, its square is V of 0 square divided by omega square plus what is B value is x of 0. X of 0 means its square is x square of 0. This is the C value obtained. Check the options. Root of V of 0 square by omega square plus x square of 0. That is the value of C is equal to root of V of 0 square by omega square plus x of 0 square. Yes. This option is okay. This option is also okay. These two options are okay. Now we need to check this phi value there. Okay. What the phi value here? Listen. What about this phi value? Comparing this equation with the given standard formula in the question. Here cos of omega t minus phi. And here it is omega t minus 90 minus alpha. Okay. We understand that this phi value is equal to 90 minus alpha. Here it is phi here it is 90 minus alpha. Okay, phi value is 90 minus alpha. Okay, now we can take tan phi here, then we will get tan inverse of something is phi value. Yes, phi value is asked here. Okay, what is tan phi is tan of 90 minus alpha, isn't it? What is tan of 90 minus alpha is cot alpha, isn't it? This is cot of alpha. Okay. Now we get from this graph what is tan alpha is b by a, isn't it? Tan alpha is b by a means cot alpha is a by b. Cot alpha is a divided by b. Okay. And what is a value is? A value is v0 by omega, isn't it? v0 by omega into b. B is x of 0. B is x of 0. X of 0. This is tan phi. Tan phi. Then what will be phi is tan inverse of v of 0 by omega into x of 0. Phi is equal to tan inverse of v of 0 by omega into x of 0. We can check the option tan inverse of v of 0 divided by x of 0 into omega. See, this one is our option C. Option C is the correct answer. Okay, students, this is somewhat a lengthy question, but it is easily calculatable by the idea of some trigonometric identities also there. Okay, practice this type of questions and boost your confidence. Okay, the next question is, in a simple harmonic oscillation, what fraction of total mechanical energy is in the form of kinetic energy? What fraction of total mechanical energy? That is, out of the total mechanical energy E, how much is kinetic energy is asked. Okay, when the particle is midway, this midway means the displacement is a by 2. Midway between mean and extreme position. Okay, that is, this displacement is a by 2. At this displacement, what is the ratio of kinetic energy to total energy is the question. Very simple. Kinetic energy formula is half into k or half into k into a square minus x square. Yes. Divided by total energy is half into small k into a square. Very good. Now half k is cancelled. Now a square minus what is x given here is a by 2. A by 2. Okay. What's the square is a square by 4. Isn't it? Divided by a square. Okay. Now a square is also cancelled, 1 minus 1 by 4. Okay. This is 4 minus 1, that is 3 by 4. Okay. 3 by 4 is the answer for this fraction. It is very simple to calculate. Option A is the answer. Clear? Yes. Now the third one. A particle starts executing simple harmonic motion of amplitude A and total energy is given E. At any instant, its kinetic energy is 3E by 4. Kinetic energy is given as 3 times of total energy by 4. Then, what is this displacement Y in terms of amplitude? What is the displacement of Y is dash times of amplitude. Small a is given. Amplitude is small a is given in the question. Clear? What is the expression for kinetic energy? We solved in the previous question that half into k a square minus x square is equal to 3 by 4 times of total energy is half into k into a square. Clear? Half k is cancelled, which means a square minus, here it is y is asked, so instead of x we take it as y. Okay, a square minus y square is, this is 3 by 2 into 4 is 8 a square. Okay, now what is this y square is? Y square is a square minus this term to this side is 3 by 8 of a square. Okay, yes. Now what it is? See, 8 minus 3. See, 8 minus 3. See, first of all, this is 3e by 4. Okay, what is this total energy? And what is the formula of kinetic energy? We have half k into amplitude square minus displacement square. Okay, 3 by 4 of total energy is half k a square. Clear? Half k is cancelled. Clear? A square minus y square is equal to 3 divided by 2 into 4, 8a square. Okay, so y square is a square minus 3 by 8 a square. 8a square minus 3a square is 5a square by 8. Clear? So y square is 5a square by 8. Okay, then its displacement is here, actually this y is equal to root of 5 by 8 into amplitude value. The amplitude value is given only small a here. Okay, this is as per the given question. See, This is total energy. This is the 3E by 4, that is the kinetic energy is 3E by 4 kinetic energy. Okay, so no mistake happened in the steps, but no options are there. So some error in the options there only, because see, once again we may check it. Kinetic energy is 3 by 4 of E is given. Okay, kinetic energy half K into A square minus Y square. 3 by 4 of total energy is half K A square. Half K cut A square minus Y square is 3 by 8 A square, and this is the answer of the question. Okay, this is the answer of the question, no doubt for that. Clear? Now the fourth question is, an object of mass 0.5 kilogram, mass of the object is 0.5 kilogram, is executing simple harmonic motion. Its amplitude is 5 centimeter. Amplitude of the motion is 5 centimeter. Okay, and time period t is given as 0.2 second. Okay, what will be the potential energy of the object at an instant t is equal to t by 4 second? Listen, suppose this is the path of the simple harmonic motion. This is mean position, this is the extreme end. Then at time is 0 second, let the body be at the mean position. Then at time is equal to t by 4, the body will be at the extreme end. Okay, see, its amplitude is given, time period is given, potential energy at time t is equal to t by 4 starting from the mean position. Yes, starting from the mean position, after a time t is equal to t by 4, the object will be at the extreme position. And what is the potential energy is asked? You know, potential energy formula is half k into x square. Half k into x square, and it is half k into, what is this? X value is the amplitude value, isn't it? Half k into a square. And we know what is k is m omega square. K is m omega square into a square it is. Now, what about the values given here or not? Mass is given, amplitude is given, and time period given, from which we get omega value. So 1 by 2 into mass is 0.5. Then omega square is 4 pi square by t square into a square, isn't it? Now 1 by 2 into 1 by 2 is 1 by 4. Okay, now 4 into pi square divided by, what is this time period given? 0.2. 0.2 is 2 into 10 raised to minus 1. Its square is 4 into 10 raised to minus 2. Okay, now amplitude is 5 centimeter. 5 centimeter square is 25 into 10 raised to minus 4. Okay, this is the answer of the question. And we can take this pi square as 10. Pi square as 10. We can take it. Clear? 4 by 4 is cut. Here it comes 25 divided by 4. 25 divided by 4 is 6 point something. And you check the options, all are this. This is, we can exclude that. And all others are 6 and 2 are coming there. And check the power of 10, we'll get the answer. This is option C. Very simple. You can easily check it. Clear? So, this is the question about the potential energy of a simple harmonic motion. Very direct. Clear? Okay, now moving to fifth one. See, the variation of displacement with the time of a particle executing free simple harmonic motion is shown in the figure. The variation of displacement is given sinusoidally. Sinusoidally means x can be written as a into sine of omega t. Okay, that graph is given here. And the potential energy versus time plot of the particle is correctly shown in figure dash. What is the potential energy formula of the simple harmonic oscillator? It is half into constant into square of the displacement. Half into force constant into square of the displacement. Okay, this potential energy depends on x square. So no negative comes there in this graph. No negative possible. Whatever may be the value of x, the square of the value is the defining factor of potential energy. Okay, so it's very clear this is not the answer. This also not that. This also not the correct one. And the only graph in which only positive is this one. And you can check the value also, we'll get it. We will get this definitely. We'll get this. Clear? Means at x is equal to 0, what is potential energy? 0. And x proceeds, potential energy increases. Okay, potential energy increases up to the extreme point. Thereafter, potential energy decreases to the mean position. Again, potential energy increases to the maximum level. Again, decreases. In this way, it varies. So, this is definitely the answer of the question. Okay, very simply understood. Moving to 6th. For a transverse wave traveling along a straight line, the distance between two peaks, that is crest, is 5 meter, while the distance between one crest and one trough is 1.5 meter. The possible wavelength of the waves are, considering a transverse wave means including this crest and trough. Okay, see the distance between a trough and a crest, you consider this, the distance between a trough and a crest. See, this is the minimum distance between a trough and a crest, and it includes a lambda by 2. This is lambda by 4, and this is lambda by 4, and this is lambda by 2. Isn't it? So we understand the distance between crest and trough. Distance between crest and trough, I may write this d1 is equal to some multiple of lambda by 2. And when we closely examine that, we understand this is 2n plus 1 times of lambda by 2. Okay, if n is 0, what this is lambda by 2. If n is 1, this is 3 lambda by 2. That is this one. 3 lambda by 2 is this one. See, you can check this. 3 lambda by 2 is this one. This distance is 3 lambda by 2. Okay, and the next distance will be 5 lambda by 2. In that way, it proceeds. Okay, and now the distance between two crests, for example, this one or this one or this one. So, the distance between two crests, we can mark it as d2, is the multiple of lambda, and let that integer be n also. So this n we can take as n1, this n we can take as n2, isn't it? So 2n1 plus 1 into lambda by 2, here in this question it is given as 1.5 meter, yes, 1.5 meter, and this is given as 5 meter. Okay, yeah. Now divide both, we get 2n plus 1 into lambda by 2, lambda will be cut, here it 2 will be there, divided by n2 is equal to 1.5 divided by 5. Okay, this one can be written as 3 by 2, 2 cut, 3 remains here, 5 into 2, that is 10n1 plus 5 is equal to, then here it is 3, 2 already cut, so this is 3n2. Clear? This is the relation connecting n1 and n2. And when you check the value of n1, different value of n1, if n1 is taken as 0, n1 is taken as 0 means n2 is 5 by 3. n2 5 by 3 not possible because it is not an integer. So this one is not possible. You understood? And if n1 is taken as 1, then 10 plus 5, 15. 15 by 3 is 5, so this n2 as 5 we got. This is one possible set of integers, n1 is 1, n2 is 5. Accordingly, we are getting a lambda. You put n1 as 1, then this is 3 lambda by 2, and it is equal to 1.5. Then 3 by 2 it is. 3 by 2 is cut, which means lambda is equal to 1 meter. Lambda is equal to 1 meter. And the next possibility is n1 is equal to 2. Suppose n1 is equal to 2, check it. This is 20 plus 5. And 25 divided by 3 is not an integer. So n1 is equal to 2 is not possible. Now n1 is equal to 3, you check. This is 3 means 30 plus 5. 30 plus 5, 35 by 3 is not an integer. So this is not possible. Now n1 is equal to 4, we check. 4, then this is 10 into 4, 40 plus 5, see 40 plus 5 is 45 by 3, it is 15, n2 is 15 possible, so this is a possible another set. And when we put n1 is 4 here, when n1 is 4 here, 2 into 4, 8 plus 1, 9 by 2 is lambda, 9 lambda by 2 is 3 by 2, we get this lambda value as 1 by 3. The first one is 1, okay, then second one is not 2, not 3, not, this is also, we remove that. Now first one is 1, okay, second one is not 2, not 3, it is 1 by 3 we are going to obtain. And automatically the third one is 1 by 5, it corresponds to n1 is equal to 7. n1 is equal to 7. So on, the lambda values are possible. So on the lambda values are possible. Okay, very easily understood. This is option C. But some steps are there. The distance between crust and trough, you remember this formula, and the distance between two crusts, you remember this formula. Students, please note these two formula, and rest of them are merely calculations. Okay. Now, seventh question is, the driver of a bus approaching a big wall notices that the frequency of his bus horn changes from 420 Hz to 490 Hz. Clear? This is a big wall here, and this source and observer and source are in the bus. The horn is in the bus, and the observer, the driver, is also in the bus. Okay, it is moving, so the sound wave is getting reflected here. Okay, now for this observer, you consider this as the source now. Okay, because the sound wave is coming and hitting the wall and reflecting, and this reflected sound waves heard by the observer, so you consider this as the source. Okay, and now this 420 Hz is, now he feels that it is 490 Hz. Okay, this is Doppler effect. Okay, now the speed of the bus is asked. The speed of bus is asked if the speed of sound is 330 meter per second. We have the Doppler equation for frequency. The apparent frequency is the original frequency into speed of sound plus or minus speed of observer divided by speed of sound plus or minus speed of source. This is the formula. Okay, we use. Now, if the observer, you take a figure there, generally you take a figure there, observer on left and source on right. Okay, if the observer is approaching the source, you take VO as positive. If observer is moving away from the source, you take VO as negative. If source is moving away from observer, we take VS as positive. If source is moving towards the observer, you take VS as negative. Okay, now in this case, the apparent frequency is 490 and the original frequency is 420 and the speed of sound is 330, and here what this observer is moving toward the source. Observer moving toward the source, it is taken as what? Positive. So observer moving toward the source is taken as positive plus VO divided by, then speed of sound is 330, now plus or minus VS. Now this is the source. Okay, this reflected wave he is observing. So the source is approaching the observer. Source is approaching the observer means this is taken as minus VO. Okay, now 0, 0 cut 49 and 42 cut by 7. We get 7 is equal to 6 into 330 plus VO minus 330 minus VO. Okay, now this is 7 into 330 minus 7 VO is equal to 6 into 330 plus 6 VO. Okay, now this one to this side means 330. Okay, 7 330 minus 6 330 is 1 330 is equal to 13 VO, isn't it? So we get this 7 plus 6, yeah, 13 VO. Then we get this VO is equal to 330 divided by 13. Okay, this is only in meter per second. Okay, meter per second. Okay, and you convert it. Okay, you convert it into kilometer per hour. You convert it into kilometer per hour by how? By multiplying with 18 by 5. 18 by 5, we get this answer as 91 kilometer per hour. Calculation is up to you. We are not spending much time on that. Just try to understand what is the concept of Doppler effect, how we put the sign properly. In any of the cases, whatever the source moving towards or what, observer moving towards or what, you take this figure, and if the source is approaching toward the observer, you take source is approaching toward the observer and VS as negative. In that way you proceed, your answer will be proper, and in this question it is 91 kilometer per hour, the question of Doppler effect. Okay, now 8th one is, assume that the displacement of AI is proportional to the pressure difference delta P created by a sound wave. Displacement further depends on the speed of sound density, the speed of sound V, the density rho, frequency F. Okay, so displacement depending on pressure difference, depending on what? for depends on the speed of sound and density of air, frequency of the wave. These things about which the displacement is depending. Okay. Now here a pressure difference considered as 10 raised to 10 Pascal, speed is considered as 300 meter per second, density is 1 kilogram per meter cube, and frequency approximately 100 hertz you take. 100 hertz you take, then only we get this as answer 3 by 100. I explain how this came. This is not 1000 you take as 100 hertz you take, and this will be the answer how it is. So the question is then S will be of the order of, what is the order of displacement is asked. Listen me. In the case of propagation of sound through air, actually there is pressure variation. Okay, there is pressure variation. Okay, and the pressure is maximum 0. So pressure varies from +1 to -1 in that range, like +A to -A in that range, like amplitude or displacement varies from -A to +A in that range, pressure also varies. Okay, so the variation of pressure is there in the case of this propagation of longitudinal waves. Okay, in that case we have the amplitude of the pressure, is the displacement value, then the wave number value k, and bulk modulus of elasticity of the wave. This equation you please remember. Okay, the derivation is out of the scope. You just remember the pressure amplitude is displacement, then wave number k, then bulk modulus. See, displacement, then wave number, wave number is omega by v. Wave number is omega by v. You should study that v is equal to omega by k. V is equal to omega by k, k is omega by v. And bulk modulus of elasticity, rho into v square. Okay, we also studied that v is equal to root of b by rho. V is equal to root of b by rho. Then what is this? B is equal to rho into v square. And this is p naught. Clear? Now S is equal to, what is S is equal to p naught divided by, this one v is cancelled here, then omega into rho v. Putting the value here 10, omega is 2 pi f. 2 pi taken as constant, then f is here, frequency I am putting here 100, not 1000. Okay, now that's done. And density is 1 here given, and the speed is given, 300 meter per second. Okay, now this is in meter unit only, meter SI unit, and the options are in millimeter unit. So I am multiplying this with 100. Okay, 10 divided by 300. 10 divided by 300 millimeter. Okay, multiplying this 100 means this 100 will be vanished. So this 10 by 300 or 1 by 30. 1 by 30 millimeter. 1 by 30 millimeter you will obtain 0.03 certain times. So that is this answer only. This answer only we are obtaining 3 by 100 millimeter. So the all important thing is the relation between pressure variation, displacement, wave number and bulk modulus value. Okay. Now the 9th question is, in a resonance tube experiment, when the tube is filled with water up to a height of 17 centimeter from bottom, it resonates with a given tuning fork. Okay, the first resonating length, the resonance tube experiment. Resonance tube experiment is there, we study in 11th standard. Okay, now the first resonance is obtained at a length of 17 centimeter. Okay, now when the water level is raised with the next resonance, this is the resonance tube, there is water and tuning fork is excited here, resonance is observed, and now water level is increased, and now again the same tuning fork is there, now resonance is again obtained at a different length. This is the length, this is the length, at a different length, at a greater length. What is that? Greater length is here 24.5 centimeter. Again resonance happened with the same tuning fork. Okay, now if the velocity of sound in air is 330 meter per second, velocity of sound in air is 330 meter per second, then the tuning fork frequency is, what is the tuning fork frequency? See, there is a direct relation between the first resonance length and second resonance length and wavelength of the wave. Wavelength of the wave is twice of L2 minus L1. Wavelength of the wave is twice of L2 minus L1. Okay, this is twice of L2 is, students, 24.5 minus 17. Okay, this obtained, we got this as 15 centimeter. You take it, calculate it. And there is lambda is obtained. Lambda is obtained means frequency is calculated. What is frequency? What is new lambda is velocity. Okay, frequency is velocity by lambda. Frequency is velocity by lambda only. Velocity is given here 330 and lambda is 15 centimeter. Centimeter is 10 raised to minus 2. Okay, solve this to get the answer 2200 hertz. Students, you please go with the calculations. It is up to you, very easily calculatable. These things are very basic mathematics, no problem. You try to understand these formulas and the questions there. Please try to understand. Okay, today we are having this much of questions there. And one more question here is, this also from the same question, Doppler effect. So we can avoid that. And up to this 9 questions you focus today, and some many other concepts. Already lot of concepts we discussed today in the offline class. Okay, and we go through with some other concepts also. Okay, keep up the good work there. Okay, boost your confidence. Okay, we hope for the good. Good night. Thank you. See you soon.
Hi dears. So, welcome back to the live DPP session of Master JEE. Today we are going to discuss about the important topic from plus 2, that is actually chemical kinetics. How many of you are ready? How many of you are there in the comment box? Come on, come on. Yes, Marwana. Yes, great to see. So, Ashmita, yes, let's start now. So, today we are going to discuss the very important question from chemical kinetics. So today we discussed many concepts in the class. We are going to discuss the question from here. So this is the first question, guys. For a first order reaction, A gives P, the temperature T, dependent rate constant K was found to be the follow the equation. Okay. So temperature dependency T and rate constant K. That equation is called what equation? Arrhenius equation, you remember. So they gave the equation what? Log K equal to. Log K equal to, they gave the equation, log K equal to minus 2000 divided by T plus 6. They gave one equation. And they are asking the pre-exponential factor A and the activation energy EA respectively. So simply I just want to compare this one with the Arrhenius equation. What was the Arrhenius equation? You know that K equal to A raised to minus EA by RT. Once we are solving that one, we will get the equation like this. You remember, log K equal to, okay, log K equal to, I will write here, log K equal to minus EA by 2.303 R into 1 by T plus log EA. This is the equation. Okay, this is the logarithmic equation of that, which one? Our Arrhenius equation. Now we just want to compare it. That's it. They are asking about the pre-exponential factor A. So we can compare this one, guys. How we can compare it? Here log A, instead of that 6 is there. So log K. Here log A 6 is there. Log A equal to 6. Log A equal to 6 means A equal to what? A equal to anti-log of 6. Anti-log of 6 is nothing, 10 raised to 6. Anti-log of x is 10 raised to x. Anti-log of 6 is 10 raised to 6. So we can check, is there any option contain a pre-exponential factor A is equal to 10 raised to 6. Option A 10 raised to 6. Option C 10 raised to 6. Option D also 10 raised to 6. We have 3. So again we can compare this to minus 2000 by T and minus EA by 2.303 R into 1 by T. So here this T common, remaining we can relate. How we can relate? Minus EA by, I hope you can see, minus EA by 2.303 R. That minus also common, so we can avoid that minus also, no problem. EA by 2.303 R, that is equal to what? That is equal to 2000. That is equal to 2000. Okay, that's equal to 2000. Now I can write EA equal to what? 2000 into 2.303 into R. We know that this 2.03 into R. 2.303 into R means R is 8.314. 2.303 into R, instead of that I can write 19.14. We discussed that idea in many times, many cases. So that means 2000 into 19.14. So 2 into 19, 38. 38 point something. This is into 1000. So 38 into 10 raised to 3. That means 38 kilojoule is coming. Is there any option like that? 38 kilojoule? Yes. Option 3, 38.3. Option D is the correct one. Option D. I hope you got it. Yes. Yes, Shiny Sabu. Nice to see. So option D is the correct one. Is it okay? Hope you guys got it. Ready? So then we can move to the next question, guys. We can move to the, so only comparison question. You have to remember the comparison. That's it. Nothing more. Okay. So simple one. So we can move to the next question, guys. This equation, this is a very easy one. Very easy one. So the reaction 2A plus B plus C plus D, okay, gives E. Okay. Here it is gives E. Gives E is found to be first order in A. So this is the equation, means we can write the right law. So this is the equation they given. 2A plus B plus C plus D, okay, gives C plus, gives D plus E, okay, gives D plus E. Then how I can write the right law? I can write the right law like right equal to K into the concentration of A raised to, I don't know what's the number. So only through experiment only I can find out. I can write X and B raised to Y. That also I don't know. And C raised to Z. But in the question they already gave the value, I hope so. Here they are telling found to be first order with respect to A. That means X equal to 1. X equal to 1. And second order with respect to B. So that means Y equal to 2. And 0 order with respect to C. That means Z equal to 0. So no need to write this one. We can simplify and we can write equal to what? K into A raised to 1. So that means A. And B raised to 2. B square. This idea okay, I hope so. Then what I can do, guys? What I can do, guys? I can simply, they are telling what's the question? What is the effect on the rate increasing concentration of A, B, C 2 times? You are increasing the concentration of A, B, C. C if you increase or decrease whatever, nothing will happen because C raised to 0 only coming. Nothing will, no change. So you are increasing the concentration of A to double and increasing the concentration of B to become double. What will happen to the rate? So simple. We can write K won't change until the temperature change. K is constant. A become 2A. I can write A equal 2A and B become 2B. So 2B square. So this is new rate. I am taking rate dash. So that's equal to here 2 is there. Here 2 square is there. So 2 into 2 square means 4. Remaining is K into concentration of A into B square. This K into A into B square is right. So that will be equal to 8 times initial rate. Rate dash is no rate and 8 times initial rate. So what's the answer? The increasing the rate by how many times? How many times the rate will increase? 8 times. Option B is the correct one. I think in option they are answering. I hope so. Yes, Nandida. Yes, that's the answer. That's it. That's the answer. Okay. Option B is the correct one. Simple one. Is it now? Yes or no? Yes or no, guys? Yes. Okay. So then we can move to the next question. 13th question. The hydrolysis of ethyl acetate. Can you see? The ester hydrolysis or inversion of cane sugar, all are we are considering as pseudo first order. Once we are seeing, we will think like that higher order, but actually follows the first order. How it is actually, it is to be higher order, how it is to be first order. The idea is simple. Answer is A. How it is to be first order, that also I will explain. CH3COO C2H5. This is ester and here H2O is there. So I can write the right law as rate is equal to, you can see guys, rate is equal to, this one I am taking it is ester, okay, ester and this is water. I can write K into concentration of ester raised to 1 and concentration of H2O raised to 1. But this H2O you will take it as excess large amount. So from that, if some little bit react also, it won't affect. That means this concentration of H2O remains constant. So this constant into this constant, this is excess. Excess means if it a little bit react also, that concentration become constant. So this is also constant. So constant into K become K dash ester dash. I mean ester raised to 1. So now we are expecting the order is 1 plus 1 2, but that's a constant. So that's why now order is only 1. So answer is first order. Okay. So whenever you are seeing the hydrolysis reaction, 99% it will be what? You have to think like that. That water you have to take excess. At least one of the reactant, if you are taking excess, means it will obey pseudo first order. Okay, pseudo first order reaction. I hope you got it. Ready? Yes, Anna. Yes, correct. Okay. Then we can move to the next question. The rate of chemical reaction doubles every 10 degrees Celsius. Okay. Whenever you are increasing 10 degrees Celsius, the rate of reaction becomes just double. And if the temperature is raised by 50 degrees Celsius, if you are increasing 50 degrees Celsius, that means how many times we have to increase? 5 times 10 we have to increase. For each increase in 10, the reaction become double. So you can use a simple formula that I already taught. So you can use a simple formula. R final, rate final, RF means rate final is equal to rate initial rate into, okay, 2 raised to delta T by 10. If it is 10 degree change, okay. So here why I am taking 2 means here they are telling what for every reaction increases by double they are telling double. They are telling that's actually temperature coefficient. That you know the idea temperature coefficient, the ratio between the rate constants within, I mean they are differ actually by 10 degrees Celsius, that is 2. If it is 3 times means you have to take 3 raised to delta T by 10. So R final, rate final equal to rate initial into 2 raised to delta T by 10. That's enough. So here rate initial, okay, into 2 into what's the delta T? 10 to 50 degrees Celsius. 10 to what? 50 degrees Celsius. You are telling you are increasing 50 degrees Celsius. 50 degrees Celsius increasing means what will be happening? Your temperature is increasing 50 degrees Celsius means that delta T is 50 divided by 10. Okay, now 10 to 50, they are simply telling you are increasing the temperature 50 degrees Celsius. From where? Somewhere you are increasing 50 degrees Celsius. 50, the change is 50 divided by 10. So this will get cancelled. So R initial into 2 raised to 5. What is 2 raised to 5? 32. 32 into Ri. So 32 times initial rate it will be become. So option C is the correct one. Hope you guys got it. Ready. Yes, Shani Sabu, Ashmita Chakrabarti. Yes, C is the correct one. Is it okay now? Ready guys? Comment it in the comment box. Comment box is simply vacant actually there. If you want to, if you are getting the answers means you have to show that in the comment box. Yes, I'm waiting. Yes sir, okay, great, okay, yes, okay. So we can move to the next question guys. This is the next question. Question number 15. A first order reaction is 75% complete in 32 minutes. First order reaction 75% complete in 32 minutes. They are asking 50% of the reaction complete in. You must have to remember T 75% is equal to 2 times T50. 2 times T50. So this one already they gave T75 they given 32 equal to 2 times T50. Okay, 2 times T50. They are asking T50. So what is T50? T50 equal to 32 by 2. That's equal to 16 minutes. How many minutes? 16 minutes. Option A is the answer. Some of you may be thinking like that, sir, how this T75 is equal to T50? How we can remember? You can easily remember like this guys. You can remember like this. Suppose you are taking R0 is the initial concentration of reactant. If it is a first order means its half-life will be always constant. So it's the initial concentration of reactant R0, and after 1 T off it become R0 by 2. Okay guys, again another T off it become what? R0 by 4. It's off. Again another T off it become R0 by 8. It will go on, continue. Okay, another T off. Now you just think about it. What? Here you can tell the remaining concentration you are representing on the top. Okay, remaining how much and reacted how much. Here initially you are taking 100%. That time nothing reacted, 0% reacted. But after T half, how much will be remains? 50% only remains. But how much reacted? 50% reacted. And after again, so now you have 50. In that 50, again 50% reacted. How much remaining? 25% only remaining. So how much totally reacted? 75%. Okay. Then again this 25% is reacting. It's half reacting means 12.5% is remaining. That means 87.5 percentage remains, I mean reacted. Now from here itself you can say, what do you mean by T 75 percentage? T 75 percentage means 75% of the reactant reacted. So 75% of the reactant reacted. For that how many T of? 1, 2. So 2 T of, okay. And similarly T 87.5 percentage, how I can write? 3 T of. This is the idea, guys. Okay, I hope you got it. From that only I wrote the answer. Okay, ready, set. So then we can move to the next question. This is also a mathematical question. For the two gaseous reactions following, data are given by A gives B, K1 equal to 10 to the power 10 e raised to minus 20,000 by T, and C to D, C become D, K2 equal to 10 to the power 12 e raised to 24,606 by T. And they are asking the temperature, at which K1 become equal to K2. So I can write K1 equal to what? K2. K1 equal to K2. What is K1? K1 is 10 raised to 10. Okay, 10 raised to 10 into e raised to minus 20,000 divided by T. That will be equal to 10 raised to 12 into e raised to minus 24,606 by T. Okay, now I am taking, what I am going to do, I am going to take this 10 to the power 10 to right hand side, that e exponential factor into left hand side. So it will be become e raised to minus 20,000 by T divided by e raised to minus 20,000, okay, not 2000, 24,606 by T. This is equal to 10 to the power 10 will go down there, means 10 to the power 12 divided by 10 to the power 10. That's equal to 10 square. 10 square, that means 100. Okay, 10 square, 100. Now what I am going to do is, you can see that is 10 to the power 12 divided by 10 square. Now what I am going to do is, this is a raised to x by a raised to m. So a raised to x minus m will come. This minus will go to top, means it will be become plus. Now I am writing in the next step here. You can see. So now it will be e raised to, you are having 4606 by 24,606. Okay, minus 20,000 divided by T. It is equal to, you will get what? 10 square. You will get 10 square. Now what I am going to do is, I am going to take natural logarithm. You can see, you can check it again. So this one will go to top, means 24,606 by T plus minus 20,000 divided by T. Here 10 square is there. Okay, correct only. So now this one e raised to, both are denominator same, that's why I kept together. Okay, so what is remaining? 4606 by T, okay, equal to 10 square. Now what I am going to do, I am going to take natural logarithm in both sides. So natural logarithm on both sides means ln e raised to 4606 by T equal to ln 10 square. We know that logarithm of a number raised to x means that number raised to x will come out. So 4606 divided by T into ln e is there, that's equal to ln 10 square become 2 into ln 10. What is ln e, guys? ln e is equal to, you can write ln e equal to what? ln e equal to 1. So I can write like what? So you can see, this is actually, I can write like, listen to me very carefully, 4606 by T is there into ln e is 1. This is equal to 2 into ln 10 is not 1. ln 10 I can write 2.303 into log 10. This log 10 is 1. Now I can take T to the right hand side. So that means T will be equal to 4606 divided by what is remaining? 2 into 2.303 means what it will be coming? 4.606. Once you are cancelling this one, you will get what? 1000 Kelvin. 1000 will be the answer. 1000 Kelvin will be the answer. Let's check, is there any option like that? Yes, 1000 Kelvin is there. Oh, this is the answer, 1000 Kelvin. I hope you got it, because if you increase the speed of mathematical things means it will be easy. Yes, Ashmita, yes, correct. B is the answer, 1000 Kelvin is the answer. Now we can go to the next question, 17th question, okay. 17th question, this is 17th question. What's the question? The ratio of the times for the T99%, 99.9% of the reaction to complete and half-life of the reaction to the complete is. So they are asking the ratio between T99.9% to T half. This ratio how much? That's the question. So before doing this one, I will explain one idea, one simple idea that you have to remember. That's a very important thing. I will teach you one shortcut. T90%. First I will tell the theory, then I will tell the shortcut. Okay. T90%. Listen to me very carefully. Those who are watching the video, listen to me very carefully. Okay, I am telling the theory. Some theory idea I am telling. T90% means what? 90% of the reactant reacted. For that, how much time is remaining? For that, how much time required? So that means I can write 2.303 by K log. Initial I am taking 100. Initial how much I am taking? 100. So 100 is there. Now 90% reacted. How much remains? Only 10. I am taking 100. Simply every time I am taking 100. Then 90 to make it easy, calculation easy. Now 90% reacted means remaining is 10. We know the equation. From that only I am writing 2.303 by K log R0 by R. Initial by final. So initial I am taking 100. Final I am taking 10. Now what I can write? This 0 will get cancelled. So what will be remaining? 2.303 by K log 10. So that's equal to 2.303 by K. Just remember, okay, just remember T90%. Just remember, I'm coming back. And suppose it is to be T99%. T99% means 99 reacted. 99 reacted means 2.303 by K log 100 I am taking initial. 99 reacted means only 1 remains. Only 1 remains. So meaning what you will get? 2.303 by K into log 100. What do you mean by log 100? Log 10 square. So that 2 you can take it outside. So what it will be become? 2 into 2.303 by K. This log 10 become 1. What is 2.303 by K? That we already discussed, that is T90%. So that's equal to 2 into T90%. So idea is simple. You have to remember T90% contain how many 9? Only 1 9. So that's why 1 into 2.3 by K. T99% contain how many 9? 2 9. So 2 into T90%. If it is to be, I hope you can follow me. If it is to be T99.9%, it will be 3 times. How many 3s are there? 3. 3 into 90%. Okay. And if it is T99.99% means how many 9s are there? 4. So 4 into T90%. That's it. Idea clear? What is T90%? Hereafter onwards for JEE examination you have to remember 2.303 by K. In that equation now 2.303 by K log R0 by R. The 2.303 by K if you are seeing, you have to remember that is T90. Every time you have to remember T90. So that T90 into how many? It means you can just count the number of 9s. That's it. Idea clear? I hope so. Idea is okay. Ashmita, idea is okay. Yes. If it's so, then we can come back to the question. T99.9% divided by T half. That only they are asking. So how I can write T99.99%? What I can write? 3 times T90. Okay, no problem, right? T90%. Okay, now understood. And what is T half? T half is equal to 0.693 by K. 0.693 by K. Okay, 0.693 by K I can write. So then what is 3 into? What is T90%? That we already told. That I already told. 2.03 by K divided by 0.693 by K. I can cancel K. I can get cancelled. Then what is remaining? 3 into 2.303 divided by 0.693. How we are getting this 0.693? During the derivation you learned 0.693 coming actually 0.3010 into that idea you remember 2.303 into 0.3010, that only 0.693. So instead of 0.693 you can write here 3 into, I am writing like this, you can see 3 into 2.303 by 0.693. What is 0.693? 0.693 is actually you can write 2.303 into 0.3010. You can cancel this one. Then 3 by 0.3 means what? 10 is the answer. Approximately 10 something, 10 point something. Is there any option like that? Yes, option D is the correct one. Is it okay, guys? Yeah, we can do it direct. You can do it direct. You can do it direct, no problem. You can do it direct, no issue. But if you remember this one means easy. Okay, now ready. Then we can go to the next question, guys. We can go to the next question, the 18th question. Listen to me. This is also important question. Repeatedly asking question. Okay, different means varieties only they are asking. So they are telling an hypothetical reaction A2 plus B2 gives 2AB. Follows the mechanism as below. This is the first step. Okay, this is the step 1. A2 reversibly gives A plus A, that's the first one. And in second step A plus B2 gives AB plus B, it is slow. And in third step A plus B gives AB fast. They are asking about the order of overall reaction. So what's the idea? We have to write the rate law. How I can write the rate law? Rate equal to K into the slowest step is the rate determining step. We learned the idea that slowest step is the rate determining step. Okay, so slowest step is the rate. So sir, how do you know that it's the first order? Okay, so which one is first order? Here they are not telling first order. They are not telling first order. We have to find out the order. Are you talking about the previous one? I hope you are talking about the previous one. The ratio of d90% of complete offer. Okay, here they will give, I think they forget to mention. Okay, it's for first order. Okay, it's for first order. It's for first order. The question is regarding first order because they won't ask regarding other orders. Zero order they won't ask. D99.9 and all they won't ask. Okay, so they will ask mainly for first order. Okay, no problem. Maybe in question they missed that one. So that's it. Okay, Ashmita, thank you so much. So here while we are coming back here, we can write like that A2 plus B2 gives 2AB. Here rate is equal to K into the slowest step is the rate determining step. So this is the slow step. So in slow step, which all are the reactants are there? Concentration of A into. We can write the stoichiometric coefficient as such. It's power 1. Because slow step, that elementary step means, elementary reaction means, elementary means single step means, in that stoichiometric coefficient we can write as the powers. And in here, and along with that what is there? Concentration of B2, all raised to 1. So people may be think like the students may be thinking like that, yeah, we got the rate low. Now the order is 1 plus 1, 2. First option will be 2. That is wrong. You are doing wrong. You have to think like that. This is your main equation. In that equation, A2 is there, B2 is there, 2AB is there, A is not there. A2 is there. So this is the intermediate. Intermediate means something is preparing and it is using in the reaction. It is not appearing in the last and initial. That is intermediate. So we have to avoid this intermediate in our rate equation. For that, obviously, they will give one equilibrium reaction, reversible reaction. Is there any reaction? Yes, first step is there. So what's the first step? A2 reversibly gives A plus A. A plus A. Then what's the equilibrium constant for that reaction? I can write equilibrium constant KEQ equal to concentration of A into concentration of A divided by concentration of A2. What is concentration of A into concentration of A? Concentration of A square. A square. This A2 I can take to left hand side. So K equilibrium into concentration of A2 will come. Now I need only concentration of A. So concentration of A equal to root of K equilibrium into concentration of A2 raised to what will come? 1 by 2 will come. Now what I am going to do? I am going to substitute. Here K is there. K is there as such. Okay. K is there as such. And concentration of A. Instead of that, what I am going to do? I am going to substitute this A. Instead of that, I am going to substitute this value. What value I am going to substitute? This one. Root A. K equivalent. Okay, into concentration of A2 raised to 1 by 2 into B2. Now you check it. K into root K equivalent, that means equilibrium, that both are constant. Constant into constant is a constant. I am taking K dash. K dash into A2 raised to 1 by 2 B2. Now you check it. This A2 is there in your main reaction. B2 is there in your main reaction. So what's the order? Here 1 by 2, here 1, total order is 1 plus 1 by 2. So that is 3 by 2. So the one and only thing I have to tell is 3 by 2. 3 by 2 means 1.5. The one and only thing I have to tell is don't write that order directly from that rate law. If they are giving the steps, you have to remember, you have to think if there any reactant you are using, if it is not there in your main reaction, you have to rearrange it. For that, they will give some kind of equilibrium reaction. Is it okay, guys? Ready? Okay, ready? Yeah, oh, then C. Okay, great. Okay, C will be the answer. Okay, ready. Whenever you are understanding new concept means you have to put the fires, you have to put the hearts, you have to come and hearts, because that only make us energy. That's the fuel for us. In this light beam and all, in front of this one, in front of the camera, no one is there. You are there, you are watching our videos, you are watching our classes and all. So you have to make us energetic by sending fire, love. Yeah, it's coming. Yes, okay, that's it guys. Okay, that's it guys. So we can go to the 19th one. It's a simple question. So what's the question? The energies of activation of forward and reverse reaction, A2 plus B2 reversibly gives 2AB are 180 kilojoule and 200 kilojoule per mole. So whenever they are talking about activation energy, today I told you we have to draw the state diagram. What's the state diagram? You have to draw a state diagram like this. Listen to me very carefully guys. Listen to me very carefully. Here this is the energy. This is the energy and this is the extent of reaction. What? Extent of reaction. So once we are drawing energy diagram, we must have to remember reactants are there. That reactants will react to form intermediate, okay, that will form intermediate, okay, or activated complex, we can tell like that. Then they will form what? Product. Here they are telling, listen to me very carefully, that reaction is reversible. So first I am going to intermediate. They are telling the activation energy for forward is 180, backward is 200. So backward is more means, obviously you have to remember, it will come here. I mean the product have less energy than that of reactant. R is reactant, product is P. So that will have less energy because reactant to intermediate only, we usually used to represent what? Energy of activation for forward. That is equal to they given 180 and product to intermediate, that only EAB, energy of activation for backward, that they given 200. If EAB is less than 200 means it will be here above, that will be endothermic, it is exothermic. Now what they are telling, listen to me very carefully, they are telling, along with that they are telling, the presence of a catalyst lowers the activation energy of both reaction by 100. They are reducing both 100. So this 180 become 80. Okay, I will draw like this. I will draw with some other color. Green color I hope you can see. I am drawing like this. Okay, green color I hope you can see. Yes, you can see. So it will come like this. So now the energy of activation for forward from reactant to here is energy of activation for forward in presence of catalyst. In green color I am catalyst. That become 180 become 80. And this become from here to here. It become 100. Now they are asking the question, this is the question, the enthalpy change for the reaction in presence of catalyst will be. If there is a catalyst or there is not a catalyst also, enthalpy change won't change. Enthalpy change is a constant because it depends only on the initial and final state. If catalyst is there, this is the path. Without catalyst, this is the path. This is the path. So the initial and final state are same. Okay, that catalyst only alter the path of reaction mechanism. So what is the enthalpy change? This reactant and product energy change is called enthalpy change. Reactant and product energy change means from here to product to here 200 is there. From here to here 180 is there. So the difference between them is only 20 only will come. What's the answer? 20 only will come. What's the answer? 20. So option A is the correct one. I hope you guys got it. Ready? Clear? Okay now, ready? So then we can move to the last question, final question. The same kind of question only, the same idea only. The reversible reaction, the energy of activation of the forward reaction is 50 kilocalorie. They are telling like that for a forward reaction. Okay, I will draw the graph again. You know that in y axis what is there? Y axis energy is there. X axis what is there? Extent of reaction is there. Extent of reaction is there. Here I am taking reactant, that reactant form intermediate or activated complex. Okay, intermediate or activated complex. For that energy of activation for forward is, they are telling for forward is how much? Energy of activation for forward is 50 kilocalorie they are telling. Now they are telling what about the energy of activation for reverse? That reverse, if it is here means, if product comes here means this EAB will be obviously greater than, EAB, energy of activation for backward will be always greater than EAF. This is for exothermic. If it is endothermic means it will come here. That time this is the EAF and this is the EAB. That time EAB will be less. In the case of endothermic, EAB will be less. Backward activation energy will be less. In the case of exothermic, backward activation energy will be more. So that means that value may be reversible. The activation energy, the energy of activation for reverse reaction will be either greater than 50 or less than 50. It depends on the reaction. So what's the answer? Either greater than or less than 50 kilocalorie. That's it, guys. We did yes. So we did what? We did 10 proper questions from chemical kinetics. I hope nowadays we are increasing the toughness. I hope you can follow these ideas clearly. Okay, now ready? Today also maths sir is not there. Karthik sir is not there. He will come and say the class in next sessions. Okay, so both physics and chemistry we completed. I hope you guys are happy. We have only very few more days are there. So don't keep the spirit. Don't waste your time. Work hard. Okay, be effective. We have to go to NIT or IIT this year itself. Don't forget. Okay. So keep that in mind. We work hard. Okay. So bye bye guys. Thank you.